Okay, your objective for lesson 10 is I will apply the distributive property as a strategy to find the total area of a large rectangle by adding two products. So there's been a lot of times that we've worked with the distributive property, and we know that the distributive property is just where you break apart the factors that we're multiplying to make it easier. So we're going to be taking a larger rectangle, and it's like we're going to be breaking apart this larger rectangle into two smaller rectangles to help us find the area easier, and taking what the area of both of those rectangles are and adding them together just like we did in the last lesson. Okay, so you've got a paper in your binder that we're going to be working with today, and it looks like this. We've got a gray rectangle, and then you've got just a blank white rectangle, and then this whole big old thing right here is a rectangle too. So please go ahead and have that paper ready in front of you because we will be using that today during the lesson. If you need to push pause to get that ready, you can do that now. So right here there are three rectangles that we're going to focus on. The large rectangle, which is this whole thing, the shaded rectangle that's right here, and the unshaded rectangle that is right here. Okay? So yours doesn't look like this, and I don't expect you to draw it to look like this, but I put in all of the square centimeters that cover the rectangle, and we're going to mainly be looking at this gray shaded rectangle right now. So on your board, or no, not on your board, but on your actual piece of paper that we have, we're going to be labeling the side links of the shaded rectangle. So whenever you can see right here how many squares I have on this side and on the top side of the rectangle, go ahead and label on your rectangle the side links. And we're working with square centimeters today, so make sure you're using centimeters whenever you're labeling that. Whenever you're ready to check your answer, you can push play. Okay, so this side length right here was 5 centimeters, and this top side length right here was 6 centimeters. So what multiplication expression or what multiplication equation can we use to find the area of this shaded rectangle? Go ahead and just write that somewhere on your piece of paper because you've got a lot of white area on your paper that you can use to work problems out when we're doing this today. So go ahead and write the multiplication equation that we would use to find the area of this shaded rectangle. Whenever you're ready to check your answer, you can just push play. Okay, so the equation I was looking for was 5 times 6. If you put that it was equal to 30, that's fine. So right here, they just put it right next to the rectangle. It's okay if you don't have it right next to the rectangle. But on the problem set, you will see it right next to the rectangles when we're working on them. So what side lengths do we already know for this unshaded rectangle? What side length do we already know based on what we have right here and right here? What side length do we already know for this unshaded rectangle? Okay, the side length that we already know is 6 centimeters, because if this right here is 6 centimeters, then down here for this unshaded rectangle, this is also 6 centimeters. So we're going to label this side 3 centimeters, because as you can see right here, there's 1, 2, 3 centimeters on this side of the rectangle. So I want you to go ahead and label this side of the rectangle and this side of the rectangle. I know right here you don't see that it's 5 centimeters, but make sure whenever you're labeling them that you do, or that you are using centimeters whenever you're labeling them. And then I also want you to write what is the multiplication equation that you're going to use to solve for the area of the unshaded rectangle. And you can put that beside the rectangle or just somewhere on your paper. Whenever you're ready to check your answer, you can push play. Okay, so this was 3 centimeters. This one down here was 6 centimeters. And then the equation I was looking for was 3 times 6 or 6 times 3. It doesn't matter the way you put it. So we know that the shaded rectangle has an area of 5 times 6, and we know that the unshaded rectangle has an area of 3 times 6. So now we're going to have to write these two expressions to help us find the area of the larger rectangle. And whenever we're working with the distributive property, the two problems that we're working on, we usually have them in parentheses, and then we have a plus symbol in between those two parentheses because we know that we're going to have to add the answer to those two equations together. So on your piece of paper, I want you to write this equation because this is the equation that we're going to have to work with to help us solve the area of what the large rectangle is. So we're writing 5 times 6 plus 3 times 6, and you're putting those two equations in parentheses, and they're going to help us find the area of the large rectangle. Okay, so now I want you to go ahead and I want you to solve for 5 times 6, and I want you to solve for 3 times 6, and I want you to add those together, and on your piece of paper, make sure you're writing what is the area of the large rectangle now after you have figured these out. Whenever you're ready to check your answer, you may push play. Okay, so we knew that 5 times 6 was 30, and we knew that 3 times 6 was 18. So when we add 30 and 18 together, we get the area of the large rectangle as 48 square centimeters. So it shouldn't say units, it should say centimeters. So just double check your answer. If you don't have it correct, make sure you're fixing that. We're going to go ahead and move on to the problem set because the problem set is a lot like what we just did, breaking apart rectangles and solving two different equations to find the area of the larger rectangle. So go ahead and get your problem set ready. Okay, so for number one, we've got 4 different parts. Number 1 says label the side lengths of the shaded and unshaded rectangles. Then find the total area of the large rectangle by adding the areas of the two smaller rectangles. So it's just like what we just did. You're just going to have to fill in the blanks that are all on your paper whenever you break apart the problem. So you see 8 times 7 right here on your paper because this whole rectangle is 8 times 7. So if this didn't have a shaded and an unshaded part and this whole rectangle was just one big white rectangle, then you wouldn't have a 5 right here and a 3 right here. You would just have an 8 on this side because this side length of this whole rectangle is 8. But as you can see, they are taking that 8 and they're breaking the 8 into a 5 and a 3 because we know that when we add 5 and 3 together, it gives us 8. So that's where they're getting this part of the equation, 5 plus 3 times 7, because 8 would really go here if we weren't breaking it apart. So now they just took the 5 and they multiplied it by 7 right here, because you have to find the area of this rectangle by multiplying 5 times 7. And then they took the 3 and they multiplied it by 7 because you have to find the area of this rectangle by multiplying 3 and 7 together. So now on your paper, you're going to have to write the answer to what is 5 times 7 right here. And you're going to have to write the answer to 3 times 7 right here. And then whenever you add those together, right here is going to be the total area of this large rectangle. So I want you to go ahead and write the answer to 5 times 7 and 3 times 7. I want you to add those together and then right here, what is the total area of this entire rectangle. Whenever you're ready to check your answer, you may push play. So we know 5 times 7 is 35, and we know that 3 times 7 is 21, and whenever you added 35 and 21 together, you should have gotten 56. So the total area of this rectangle was 56 square units. Okay, right here, there is one side length missing. We don't know the side length for this shaded rectangle. And once again, there are some blanks over here on the paper that you're going to have to fill in. There are a few more blanks on this side because over here we knew what both side lengths are. So you're going to have some extra blanks because you're going to have to fill in those blanks for what this side length is. So on your paper, I want you to go ahead and find this side length of the rectangle, the shaded rectangle, and I want you to write it right here. And we're also going to write it right here on this blank because we already know that one side length is 2. We're just trying to figure out what the other side length is. And remember that when you add those two together, it should equal 12. So you're really asking yourself, what can you add to 2 that's going to give you 12? And to double check your answer, all you have to do is count down this column right here to see how many squares there are. So I want you to go ahead and label this side length and make sure you're writing that number right here on the problem set. And whenever you're ready to check your answer, you can push play. Okay, so the side length was 10 because there are 10 squares right here, and I know that when I add 10 and 2 together that it gives me 12. So right here on the paper, you also needed to put 10 because 10 plus 2 is equal to 12, and we're breaking apart the 12 right here. So we're really saying 12 times 4, which is the same thing right here, but now we're going to break it into two separate equations. So for this one right here, you're also needing to put a 10 because we're going to have to multiply 10 times 4 to find the area of the shaded rectangle, and we know that we're going to have to multiply 2 times 4 to find the area of this rectangle. Okay? They already have 8 right here for you because they already solved 2 times 4. Now you need to solve 10 times 4 and write that number right here. And then you're going to add that number and 8 together to find the area of the total rectangle. So whenever you're ready to check your answer, you may push play. So I know that 10 times 4 is 40. So this shaded rectangle had an area of 40, and this white rectangle had an area of 8. And when I add those two together, I get 48. So the area of this large rectangle is 48 square units. When you look at C and D, there's one side length for C, and there are 2 side lengths that are missing. And then for D, all of the side lengths are missing. So I'm going to let you go ahead and work on C and D yourself. It's simple. All you have to do is count the side lengths and fill in the blanks. And whenever you're ready to check your answers, you may push play. Okay, so for part C on these rectangles, for the shaded one, the side length was 10. And for this white part of the rectangle, the side length was 3. And for both rectangles, this one side length was going to be 6. So altogether, the whole rectangle to find the area would have been 6 times 13. So they broke the 13 up into 10 and 3. So this blank right here was a 10, and they already had the 3 for you. So we were multiplying 6 and 10 together to find the area for this shaded rectangle. So you needed a 10 in this blank to represent the shaded rectangle. And then they already had this other white rectangle for you, 6 times 3. So now you had to solve 6 times 10, which was 60. And then you needed to solve 6 times 3, which was 18. And then you had to add those two together to find the total area. So the total area was 78 square units. Okay, so for the shaded rectangle and for the white rectangle, they're both going to have a side length of 8. For the shaded rectangle, this side length is going to be 10, and this side length is going to be 2. So down here, the whole rectangle, to find the area, you would have had to do 8 times 12, but we're breaking 12 up into 10 and a 2. So this right here would be 8 times 10 plus 2, because you would have to do 10 plus 2 to get 12. So now you write your two multiplication equations, which is 8 times 10, and that's going to be for the shaded rectangle, and 8 times 2, which is going to be for the white rectangle. And then you had to solve 8 times 10, which was 80, and you had to solve 8 times 2, which was 16, and when you add 80 and 16 together, you get 96, so the area for this large rectangle is 96 square units. Okay, you need to flip over to the back side of the problem set. Number 2, Vince imagines one more row of 8 to find the total area of 9 times 8 rectangle. Explain how this could help him solve 9 times 8. So he's imagining a whole other row down here to help him find the area of 9 times 8. So explain how is that going to help him solve 9 times 8? Okay, well, whenever you're looking at it, let's see how many rows he has to begin with. He had 1, 2, 3, 4, 5, 6, 7, 8, 9, and there was 8 in each row. So if he added one more row of 8, he really has 10 rows of 8. We know that we can solve 10 times 8 a lot easier than we can solve 9 times 8. So right now, Vince is really thinking of his rectangle having 10 rows with 8 in each row. So if he could figure out how much he had with 10 rows, then all he would really need to do was just take away 8 of those square units that he added, because he just added 8 squares right here. So if he had 80 to begin with, because we know that 10 rows of 8 is 80, all he would have to do is take away these 8 squares that he added, and that would leave him with the area of this 9 times 8 rectangle. So I want you in your own words explaining how him doing this could help him find the area of his 9 times 8 rectangle. And whenever you're ready to check your answer, you may push play. Okay, I put that this can help Vince solve 9 times 8 because now he can think of it as 10 times 8 minus 1 times 8, which is 80 minus 8, so the area would have been 72. I was really looking for your answer to include that it would help him because he could have done 80 minus 8. So if you didn't put that it was 10 times 8 minus 1 minus 8, or minus 1 times 8, then that's fine with me. But I was looking for your explanation to include that he could have done 80 minus 8 to make it easier for him to find his area. So if you need to correct that, make sure you do that. Okay, number 3 says shade to break the 15 by 5 rectangle into 2 smaller rectangles. And I went ahead and left up how it should be shaded because I do want you to go ahead and shade it like I have shaded. And the reason that it's shaded this way is because we are working with easy factors, which are 10 and 5. And we always go to those factors whenever we can because we know that we can skip count by 10s and 5s pretty easy. So go ahead and shade this big rectangle into 2 different rectangles on your paper and go ahead and label the side links like I have it. And you need to put 15 times 5 because this whole rectangle was 15 times 5, but we're going to go ahead and break up the 15 as you can see into 10 and 5. So if you would put your paper and make it like I have mine right now, where you have it shaded and you have the 15 times 5 equation. And whenever you're ready to move on, you may push play. Okay, so we know that with 15 times 5, we broke it up into 10 plus 5, and we're still having to multiply by 5 because this side length of this white rectangle is 5, and this side length of the shaded rectangle is still 5. So if you will, go ahead and put this on your paper to show how we're breaking apart the 15 into a 10 and a 5. And then we're going to show where we have the 2 different multiplication equations that we're going to use to solve this big rectangle to find the area. So you're needing to put 10 times 5 plus 5 times 5 because those are the 2 equations that we need to solve. And then now you can see that we have 2 other equal signs because we're going to have to find the answer to this and find the answer to this, and then you will have to add those together to get the actual area of this entire rectangle. Okay, so once you have this answer plus this answer and then the actual answer written down on your paper, you can go ahead and push play to check those. Okay, so you should have had 50 plus 25, and that is equal to 75, and we are talking about square units when we're talking about this rectangle, so if you did not include square units, I want you to go ahead and put that because that's the total area. And then it says, explain your thinking. I'm not really worried about that part as long as you've got these steps written down. I will show you what I was looking for, but we knew that the total area was 75 units, and the way that we figured that out is because we broke apart 15 into 10 and 5, and those are easier facts to use, which I said a while ago, and it made smaller rectangles, and then we added to find the area of the larger rectangle. So anytime you're having to do anything like this and you're explaining your thinking, you're just explaining the different steps that we take to find the area. So on your paper, if you would just copy this down so that way you know exactly how to explain your thinking if you have to do that in the future on a lesson that we do. Once you have that finished, you will be moving on to the exit slip, and make sure you bring that to me with all parts finished and we will check it together.